Okay, so in this video I'm going to have a look at the trapezoidal rule. I'm going to look at where it comes from and a couple of examples how to use it. So here on the right hand side here we have a trapezoid or a trapezium, depending on where you come from. So it's basically a quadrilateral where two of the sides are parallel. This is our height h here. So if you want to find the area of a trapezoid, it's going to be the average of the parallel sides, so it's going to be a plus b over 2, the mean of the parallel sides, and then you multiply that by h. So what we're going to do here is we're going to find, or approximate anyway, the area underneath this curve between these two blue lines here. What we're going to do is we're going to make trapezoids, and we're going to find the area of each of those trapezoids, add them up, and that will approximate the area underneath our curve. So let's start by looking at the first trapezoid here, which is going to be, let's say, from here to here. Then we can connect that up there. There's a trapezoid there, and here's another one. So we'll just join that up there. And this is a third one. I'm going to join that up, and I'm going to come out here to the end now. So I'm going to make two trapezoids out here, and that's it. So there are a certain number of trapezoids then in between as well. So this is going to be my x1, this is x2, this is x3, x4, this is going to be xn, this is xn minus 1, this is xn minus 2. So I'm not saying exactly how many trapeziums or trapezoids I have underneath this curve. So what we're going to do is we're going to derive the formula, in other words. So let's have a look at what we've got here. We've got all these trapezoids underneath the curve. If we find the area of all these trapezoids, add them up, it'll approximate the area underneath our green curve between x1 and xn. Now, one or two more things I've got to put in here. So let's say the height from here to here, we'll call that y1. So in other words, if I put x1 into my function f, I'll get out this y value here, and that height, that's going to be the distance from there to there. It's going to be my a, if you like. It could be that distance there, or it could be that distance there, depending on which side. I guess if you turned it this way, it's going to be this side here. And this here is going to be what I get when I put x2 into the function. I'm going to call that y2. This is going to be y3, y4, and so on. This is going to be yn. This is going to be the yn minus 1. This is yn minus 2. So they're what you get when you put these x values into this function here. They're going to be those y values there. Okay, so these are our values then. So the next thing I've got to put in here is the distance between here and here. I'm going to call that h. And it's the same the whole way along. The distance between here and here is also going to be h. The distance between here and here, also h. So that's h there and h there as well. So I have all my letters in. This h is basically this value here. So let's see, we want to find the area underneath the curve. So the area is going to be approximated by the area of this first trapezoid, which is, let's see, y1 plus y2 divided by 2. That's this part here. And then we've got to multiply that by the h, and that's the area of our first trapezoid. Our second one is going to be y2 plus y3 divided by 2. We've got to multiply that by h. The third one is going to be y3 plus y4 divided by 2, and again multiplied by h. And then I'm not going to do any more there. I'm just going to do the one at the very end, which is yn minus 1 plus yn divided by 2, which we also multiply by h. Okay, so what we can do now is just simplify this. Let's see what we've got here. In each term we've got a h over 2. Got a h over 2, a h over 2. So I'm going to factorize that outside the bracket. Inside the bracket then we're left with y1 plus y2 plus y2 plus y3 plus y3 plus y4 plus all the way out to yn minus 1 plus yn. That then can be simplified a little bit further. We can see here we have a y1 and we have a yn. So I'm going to put those together. That's the first one. That's the last one. And then you can see that we have 2 of everything else. We've got 2 y2s, 2 y3s, we will have 2 y4s, and we will have 2 yn minus 1s. So let's just say plus twice y2 plus y3 plus y4 plus all the way out to yn minus 1. And that's it. That's our formula for the area underneath the curve. I should really put approximate here. It approximates the area underneath the curve. And this is the formula that you'll see in your tables. Okay, so let's do an example of how you would actually use this. Let's take this function here, which I've drawn, and it is the function 1 over x. And what we're going to do is we're going to find the area between 1 and 5 on the x-axis of the function 1 over x. So first thing you've got to do is divide it up into a certain number of trapezoids. Now the more of these trapezoids you do, the more accurate the area is going to be. I'm just dividing it up here into 4 trapezoids, 1, 2, 3, 4. So let's just join this up to this. You can see that's going to be slightly overestimating the area. This one here maybe slightly overestimating it as well. This one fairly close, and this one fairly close as well. So let's apply our formula. Our formula is area is going to be approximately equal to h over 2. Now remember, h is this distance here, so that distance there is going to be 1. You can take this value minus this value, so 5 minus 1, and then divide by the number of trapezoids that you've divided it into. So in this case it's going to be 4. So that's going to be 4 over 4, which is 1. So that's h. So it's going to be 1 over 2 times the first one, which is what we get when we put 1 into this function here. So if we put 1 into this function here, we get 1 over 1, which is 1. So this distance here, this height here, if you like, or this y value here is 1. So that's going to be 1 plus the last one, which is this one here. This is our yn. So if we put 5 in here, we'll get 1/5. So in other words, if I come over here, this value here will be 1 over 5. So it's 1 over 5 plus twice the rest of them. So we've got this one here. So if we put 2 in here, we get a half, 1 over 2, which is a half, plus, let's put this one in here, that's 3. So we've got to put 3 in, so that's going to be 1 over 3. Plus, we put our final one here, which is 1 over 4. So this here is going to be 1 over 4. And that's our area there. We've just got to work that out then. So that's going to be equal to 101 over 60, let's say units squared because it's area. Okay, that's one example. Let's have a look at another one. So let's have a look at this one here. So fairly straightforward one again. The area here is just going to be h, which is 2, the distance between here, 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 and here, and so on. Just 2 over 2 times the first height. It's kind of a common mistake people make is that they start here. Because they see a 0 here, they don't include it. But if you start here, you're not including this area here. If you finish here, you're not including this area here. So you've got to start at 0 here. So the first y value, if you like, is 0. The last one is also 0, plus twice the remaining ones then. So it's just 6 plus 8 plus 6 plus 9 plus 6 plus 5. And that will give you, again, here it's approximate area. That equals 80, and again, let's say units squared because it's area. Now just one last thing, if you do have one that maybe looks like this, let's say we have our x and y axis here, and let's say the curve looks something like this, and let's say it also comes down here as well, and we can divide it up into various trapezoids again. Let's say it's divided up like that, and what you can do here is just find the entire area here, 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 and so on. Or you could find this area and this area separately and add your two answers. But let's say this was 6, for example, and this was 7. This was, I don't know, 8, and let's say 7 again. Let's say 6 and 7, 5 and 7, 4 and 6, 4 and 7, let's say, and this again, of course, is 0 and 0 here. And let's say the distance along here again, let's say is 2, 2, 2, 2, 2, 2, and 2. So again, here what you can just do is say, let's say the area here is h, which is 2 over 2, times the first, so you can combine these two here. You can combine these two here, you can combine these two here. So again, we're going to start at 0, we're going to end at 0, and then it's twice, so it's 6 plus 7, so that's going to be 13. It's going to be 7 plus 8, which is 15. You've got 6 and 7, which again is 13. You've got 5 and 7, which is 12. 4 and 6, 10. 7 and 4, 11. So you can do it this way. So I won't actually do that out, it's fairly straightforward, just simple calculator work, but that's one way of doing it if you just want to do it all together, or as I say, you could just do that one and that one separately and add your two answers. Okay, so that's it for the trapezoidal rule.